Hello, y'all. My name is Mr. Laughlin, and I get to be one of your science teachers this year. I'm going to be focusing mostly on chemistry with you. Um, just a little bit about myself. I have a wonderful family, a wife, and a kiddo. We are so excited to be in Italy soon. Sorry, I'm not there yet. Um, I love to rock climb. I love to play music. And I love chemistry. And today we're going to talk about some of the most basic uh, concepts in chemistry. We're going to look at some vocab, and then after you watch this video, you'll do a little bit of work around some of that vocab to try and remember what we learned today. So we're going to talk about solids, liquids, and gases. We will define each of these. Before we do that, I want to give you some other vocab, make sure we're all on the same page. The very first word that I need you to know is matter. And matter is what this whole class is about, and it is any substance that has mass and takes up space. And something that has mass has weight, right? So matter is anything that has weight to it, has mass, and takes up any space at all. So, for example, your shoes are matter. The air you breathe is matter. Water is matter. So sometimes things are matter that you can't even see. Like the air you can't really see, but there are tiny, tiny particles, which is our next word, in the air, and that have a tiny amount of mass, tiny amount of weight, and they do take up some amount of space. Um, a particle is a small piece of matter. So, for example, a proton, which is a very tiny piece, an atom, also very small, a molecule, those are all particles, super tiny. You cannot see them with your eyes, um, but they do exist, they do have mass, and they do take up space. And then the last word I need you to know is volume, which is just a measurement of how much space something takes up. So, for example, 1 liter would be a volume of milk. 100 centimeters cubed, that's a volume. 50 milliliters of oil. Those are all measurements of how much space those things are taking up, right? Matter is anything that has mass, takes up space. Particle is just a tiny piece of matter, and volume is the measurement of how much space something takes up. So, as we start to talk about our states of matter, so the forms that matter can take, we'll start with solids. Sometimes these are also called phases. So, phases or states of matter. That's what we're going to talk about today. Solids, you're probably sitting on a solid or standing on a solid right now, which is like the chair or the ground. And solids have a fixed volume. Remember, volume is the amount of space something takes up. So the amount of space that a solid takes up does not just change for no reason, right? Your desk does not suddenly grow. Solids also keep their shape, so they will not suddenly become something else for some reason. Your desk will not change into a watermelon, right? They have a surface boundary, so you can set things on your desk and it doesn't go straight through it. And the particles, the tiny parts of matter, are tightly packed, right? They're all packed together, which is one of the reasons they have a boundary. And that means that the particles are not moving as much as some of the other states of matter, right? And in this case, we have a nice ice cube to represent a solid. We threw it in a cup. Here's another picture of ice. Beautiful solid water. Our next state of matter is a liquid. And liquids have different properties than solids. Some of them are the same, but some of them are different, right? Liquids do not behave in the same exact ways as solids do. And a property is like the inherent quality of the thing. So a property describes the how that thing interacts with other things, right? So some of the properties of liquids are they have a fixed volume, so they always take up the same amount of space, right? If you pour in a liter of water to this cup and then pour that liter out into a different cup, you will still just have a liter, right? They do have a surface boundary. You can see it here. You can throw things into it, right? It might pass through the boundary, but this boundary separates the liquid from the gas above it, right? This is something different, right? They take the shape of their container. So when you pour a liquid in, it becomes whatever shape you put it in, which is different than solids. And liquids flow as particles and they slide past one another. So the tiny bits of matter are no longer stiff and all organized. They are flowing around next to each other. So this is kind of to reiterate, liquids have a fixed volume, but no fixed shape. They have weaker forces of attraction between their particles than solids, which allows their particles to slide past one another and the liquids to flow. So each of these particles has a force that's attracting it to the particle next to it, right? I'm going to go back for a second. In solids, that force is strong, so they don't move much. But in liquids, it's a little less strong so that they can move around a little bit more. Or in reality, it's a similar strength, but they have more energy, so they're able to move past each other. Right. There's a nice picture of liquid water. Third state of matter is gas, and gases are very different. They have no fixed volume, so a gas will fill up whatever container you put it in. If you put these 4 particles of gas into the room you're in now, it would fill up the room because they don't have a fixed volume. They take the shape of their container. That's similar to liquids, but they do not have any boundaries, right? No surface boundary. And the particles are moving around freely, so they're no longer close to each other. They're far apart, and they are moving around and bouncing off of things and bouncing off of each other, right? So gases are very different than solids, let's say. And liquids and gases are both fluids, which means they can move, the particles can move past each other. But a gas is a different thing than a liquid, even though they're both fluids. There's a nice picture of gaseous water, right? This is boiling the water, and the gas is escaping into the room